Hi, my name is Sean and I will be walking through this demo. After this demo, I will show you the feature-based roles I was responsible for and walk you through the code that I did. And the rest of the members of my group will introduce themselves later and they will walk you through the code they were responsible for. So starting off, we will look at a patient flow. So let's log in as a patient, Billy Bob. Now, we will navigate to patient and we'll navigate to find an expert. So since Billy Bob already has a zip code in the database, we will auto-populate this field right here. And to give you some to give you some information about our database, we currently have 2 hospitals, and they total have 6 specialists, ranging different type of specialists, and those will aid in our demonstration today. So first, let's say I was looking for a pediatrician in my home zip code, and let's say I didn't really care about how far this was, so I inputted a radius of 25. So hitting submit, we can see that we created a table with we were able to find 2 hospitals in this range that held a total of 3 specialists. So you can see the hospital name, the hospital address, and the specialist name and the specialist email displayed here. So let's say instead that we wanted to find somewhere that was closer, and we know Duke Raleigh Hospital is right down the road, so we can input a smaller radius like 5, or we have the functionality of not putting a radius in at all and it'll default to 5. So let's hit submit, and you can see here we are able to find a closer hospital, which was Duke Raleigh Hospital. Now, to go through some other subflows of error checking, let's say, for example, the zip code was not a proper format of 5 and 4 optional, dash and 4 optional digits. So say they only put 4. They're met with an error message invalid zip code, and they're not allowed to proceed with the submit option, so they would have to input a valid zip code. That goes for radius too if they input a text-based radius. So 10, the field is invalid, and they're start from proceeding. So they don't want to check with their home address. So let's say they wanted to check somewhere that was a little further, maybe their daughter's house. So let's say they input a zip code such as this and hit submit. Okay, so they were able to find the UNCRS hospital with this zip code and radius 5. So that goes for our specialty search, for a specialty search for the patient. Let's move on to the healthcare provider. So let's log in as the healthcare provider and navigate over to find an expert. So since the healthcare provider needs to input a zip code and they don't have a default zip code, we are requiring them to input a zip code in the initial, and they are met with this message and they're not allowed to move forward unless they do. So let's input a zip code. And let's say the current patient was looking for a cardiologist with a radius of 10. And let's see if we are able to find a hospital in this range. Okay, so we do, and we're able to find specialist Bob Dillon, which is a cardiologist in our database right now, and he currently works at Duke Raleigh Hospital. For another case, let's say, for example, they want to look for a neurologist. So currently we don't have a neurologist in our database. We're in a hospital, so we should be met with the no current providers found message right here. So I think that covers our demo for today, and yeah, thank you. One more feature that I forgot to include was the logging function. So as you can see here, we do have functionality that displays our previous demo, what we had in the previous demo, where we searched for a user and where we included an error for the zip code. So I just wanted to add that too. So the feature-based roles that I was responsible for consisted of adding personnel to hospital, creating specialty enums, creating the output and input forms for the front end and back end, displaying hospitals, and creating the cucumber test. So to start off with the personal hospital, this is the code that I was responsible for. Essentially, just adding a field to allow multiple specialties, multiple personnel to be added to a hospital. This way that a hospital can have a specialty when users search, and it can display here. In addition, I created the enum so that we can group and restrict the type of specialties that a user can select, and this is associated with the endpoint that allows the front end to grab all of the specialties and display them in the drop-down box. And I also was responsible for creating the output and input form. So hospital search form is the form that will be returned to the front end. That's the HTML will parse and output. And the search form is the form that consists of all the input from the user, and this is sent to the backend, and it includes zip code, profession, range, and this is the code that represents that. In addition, I took the responsibility of displaying hospitals, and most of this code encompasses that. It takes the hospitals that is retrieved from the endpoint that Conda creates, and it will display all the hospitals in a table format, including their name, the address, and the specialty name and email. I also included error checking in this feature, which checks for invalid zip codes or if an HCP hasn't entered a zip code yet. And then finally, I was responsible for Cucumber testing, and Connor had created a feature file, and my feature file that reflected our system test plans, and my responsibility was just to translate this to Selenium and Cucumber test.
Hi, my name is Connor Surgat, and I worked primarily on the back end for the iTrust2 Use Case 26 project. And I'm going to walk through some of the code that I implemented and explain how it fits into the larger system. So the first task that I worked on was uploading the sample data of zip codes into the server. So the example code here given is an excerpt from the zip code class, so we can see that it's stored through Hibernate as a string and two doubles holding the zip code and then the latitude and longitude respectively. We also see some of the final static double fields that were used for input checking to make sure that it was a valid zip code that is going into the system. And this zip code is a Hibernate object, so it's stored in the MySQL server and is able to be accessed through the regular kind of Hibernate methods. And that was then used in the larger system to check when the user searches for a zip code, what is the latitude and longitude to compare distances. And the way those were uploaded was just would read through the comma separated value file and make zip codes and then save them all at once. So this is a excerpt from the REST API endpoint. So as we can see at the top of the code, we used a put mapping. This is so that we could get some data back and also put a request body in there. We ran into some trouble when trying to use a GET request for that. As it takes a search form, this search form contains in it a zip code that is the zip code that the patient is searching from, or HPC is searching from, a specialty, which is the profession that they're looking for, and a range, which is the range in miles of how far around that zip code they want to search for. So this method is kind of a wrapper. It contains a lot of error handling, including in looking to get an actual zip code object from that getZip method, or from that getByZip method. And as noted in comments, that getByZip method actually checks for both formats. So if the user input a 5-digit zip code or they input a 5-digit followed by a dash followed by a 4-digit zip code, it will check first the zip code they put in, and then if it is a longer zip code, it will cut off the end and check for that afterwards. And then it calls the logic of calculating the distances is checked in the get hospitals in range helper method. And then after that method returns, we see it does some logging and returns the response entity to send it back to the front end. So this is a look into the helper function, which you can see kind of does a little bit of error checking, and then also starts to look to the hospitals and compare the ranges. So this will find all the hospitals, put them into a queue that will be sorted, that then sorts them by how close they are, and it then goes through them all again and adds them and the specialists in them to a form that is returned and eventually passed back to the front end. This is a method that is called indirectly by the REST API endpoint. This determines the distance between two points given their latitude and longitude. This method this mathematical function that's shown below was found from the resource given for the project. and is able to convert that distance from the latitude and longitude coordinates into a distance in miles, which is used for checking if that particular hospital is inside the range. This shows some of the test methods, or the test methods used for testing the REST API endpoint. It uses some sample data and then also gives bad inputs to see if the results returned will be what we expected.
My name is Riley Gregorio, and I contributed to the front end of the guided project. Here you can see the selection menu for each individual item that you enter in to search for the expert in your area within your zip code. Above each item is a title bar, which displays the information of what you are to enter in, and below is the actual form in which you enter in the specialty, the zip code, and the radius. Here's the CSS that is used to display the front end. There is the information for the title bar, the select option, the submit button, the input, the table, the invalid displays, and the shadows that are applied to some of the items. Here is the visualization of the front end that I contributed to. Above each form, you can see the titles for which you are supposed to enter the information. There's specialty, zip code, and radius, and beside them you can see the error messages that will be displayed for the invalid information. And below that you can see the submit button.